cosine rule, which of course relates to that same triangle with angles A, B and C and opposite sides being the lowercase letters. For any triangle ABC, we can use the cosine rule. A squared equals B squared plus C squared minus 2BC cos A. If you just try the cosine of 90 degrees, you'll find that it is equal to 0. So in the case of a right-angled triangle where A is right-angled, the cosine rule reduces to Pythagoras' theorem. We can solve, just like we could with the sine rule, for unknown sides and angles. The cosine rule can be used to solve triangles if the following information is given. Either we know all three sides of the triangle, or two sides and the included angle. The included angle, if we know A and B, the included angle is the angle between A and B. There is no possibility of an ambiguous case with the cosine rule. Consider the following: sine 30 degrees and sine of 180 take away 30. So we looked at this in the previous examples on the sine rule, but if I do sine 30, it's going to be 0.5. That's one of the tests that we use to make sure the calculator's in the right mode. And 180 take away 30 is 150. If I do sine 150, that's also 0.5. And that's why we get the ambiguous case with the sine rule. But if we try cosine of 60 and cosine of 180 take 60, watch what happens. The cosine of 60 is 0.5. But if I do the cosine of 120, that is negative 0.5. So there's no possibility of an ambiguous case with the cosine rule. That's because if we just look at angles from 0 to 180, there are two angles which give you the same value for sine, but there's only one angle that will give you the cosine.